Humans are deeply uncomfortable with pure chance. When faced with a string of completely random events, our brains instinctively scan the noise, desperate to find a hidden pattern or a logical narrative to explain it all. To test just how far this obsession goes, Princeton economics professor Burton Malkiel ran a simple experiment. He generated the daily closing price for a completely fake stock by flipping a coin. Heads, the price went up a half point. Tails, it went down. This animated line graph shows the result of those flips. Notice how it builds the organic-looking peaks and valleys you'd expect to see on Wall Street. Malkiel took this exact chart to a technical analyst, someone trained to predict market movements by interpreting historical patterns. The analyst took one look at the completely random data and urged Malkiel to buy the stock immediately, claiming that history was clearly about to repeat itself. The analyst fell into a classic cognitive trap. He confidently projected a trend, a cause, and a future outcome onto a sequence of pure mathematical chance. You see this same glitch in human logic outside of finance, too. Nobel laureate Daniel Kahneman once spent time observing military flight instructors. The instructors noticed a frustrating trend. Whenever they praised a pilot for a flawless maneuver, the pilot's next attempt was almost always worse. But if a pilot executed a terrible maneuver and the instructor screamed at them, their next attempt usually improved. From the instructor's perspective, the conclusion was obvious. Screaming and punishment produced better pilots, while positive reinforcement ruined them. But Kahneman realized they were ignoring a basic statistical law called regression to the mean. An exceptionally perfect flight, or a dangerously bad one, is a statistical outlier, a rare event that sits at the extreme edge of a pilot's typical performance range. Because those extremes are rare, the odds dictate that the pilot's very next attempt will naturally drift back closer to their average skill level. The screaming didn't fix bad flying, and praise didn't cause sloppy flying. The math simply corrected itself. When we mistake this kind of statistical gravity for a direct cause and effect, we end up building systems, whether in education, management, or investing, that completely misunderstand the actual forces at play. To see how random chaos actually organizes itself, we have to look at a device invented by the 19th century scientist Sir Francis Galton. It's called a Galton board. You drop a single metal ball bearing into a matrix of pegs. Every time the ball hits a peg, it has a 50-50 chance of bouncing left or right. Its exact path is completely unpredictable. But watch what happens when you drop 10,000 balls through the exact same chaotic system. They stack up at the bottom to form a perfectly symmetrical bell curve. The logic here is strict. To land in one of the far edges, a ball has to bounce in the exact same direction dozens of times in a row, a highly improbable event. But there are thousands of zigzagging paths that lead to the center. In 1900, a young French mathematician named Louis Bachelier realized this physical device held the secret to financial markets. Bachelier looked at charts like this one, showing the jagged, erratic movements of the Dow Jones Index. He argued that every individual buy or sell decision by a trader acts just like a brass peg, bouncing the asset's price left or right in what mathematicians call a random walk. You can never predict exactly where one ball will land or what a stock price will do tomorrow. But if you zoom out and look at the system as a whole, that individual chaos is bound by incredibly rigid statistical laws. When Bachelier calculated how these price probabilities spread out over time, he stumbled onto a strange parallel. His formula was a direct match for the equation discovered by Joseph Fourier in 1822 to describe how heat radiates. If you heat up the center of a metal rod, the temperature slowly diffuses outward from the hot zone to the cold ends. Bachelier realized that the possible future prices of a stock spread out from its current price in the exact same way. For decades, Bachelier's work was ignored. But in the 1970s, economists at MIT resurrected this exact physics concept to build the Black-Scholes equation, a mathematical model for pricing options contracts. In this model, financial volatility is treated exactly like thermal conductivity. An asset with high volatility spreads its potential future prices rapidly, just like a highly conductive metal spreads heat. But the economists had to make one crucial adjustment to the physics. Look at this animated probability curve. Because a stock price can never drop below zero, the left side of the bell curve hits a hard vertical wall. To compensate, the right side stretches out into a long asymmetrical tail. Mathematicians call this a log-normal distribution. The models that dictate options pricing, risk management, and the flow of trillions of dollars today are not based on human intuition. They are anchored to the physical laws of thermodynamics. If the movement of money follows the same laws as the movement of heat, we have to consider what this means for the broader structures of our lives. If we zoom out far enough, do we see the same invisible hand organizing human society itself? Think of a single human life as a ball dropping through a massive social Galton board. Every micro decision you make, a career move, making an investment, or even an opinion you share, is a bounce off a social peg. On their own, these choices feel like an expression of pure free will. But when you multiply these micro bounces by millions of individual people, a rigid statistical order begins to emerge. In any large population, the average behaviors naturally cluster in the center, creating the stable bell curve of cultural norms that we call the middle class or mainstream society. Just as it's mathematically possible for a ball to bounce right every single time and land at the far edge, a vast population will always produce a few extreme outliers. This is why we see 1 in a million outcomes, like the extreme concentration of wealth or a viral cultural shift. These aren't necessarily the result of a grand design. They are the statistical necessity of an edge. The next time you witness a wild economic swing or an inexplicable societal event, do not look for a secret conspiracy. You are simply watching the inevitable physics of a massive Galton board, quietly finding its mathematical order.